I'm Braden Schwenke.
I'm Gregory Comer.
And I am Stockton Slack. And this is our ECE 3710 final project for microcontrollers. For our final project, we decided to take an Etch A Sketch and we attached some stepper motors to it, and using our microcontroller, we powered it to be able to draw an image on the Etch A Sketch.
The requirements for the project are to be able to take an image on the computer, process it into a path, transmit the path to the microcontroller, and then have the microcontroller trace out that path by controlling the two knobs on the Etch A Sketch. For the hardware portion of our project, we've got two stepper motors, one to drive each of the knobs on the Etch A Sketch. They're mounted to the Etch A Sketch enclosure so they move as little as possible. The motors are driven via a PCB which we've created, which uses the ULN2003 Darlington array chip, which we've previously used to drive the motors as part of the labs. The STM32L4 discovery board sits right on top of the driver board, and the microcontroller here controls the driver chips via GPIO. The microcontroller itself interfaces to the computer via USB, and the driver board is powered by an external 5-volt supply.
For the image processing portion of our project, we decided to use a open source software called OpenCV, which stands for Open Computer Vision. And this software allows us to load into our code an image like the one shown here. And this allows us to go through a few different steps as we are preparing the image and the data to be sent down to the microcontroller. First, we take the image and we perform a grayscale on it using OpenCV, and that turns the image into this. This allows us to prepare to do the edge detection, and before we do the edge detection, we also apply a bilateral filter. That smooths out some of the rougher edges and makes it more clear so that there are distinct edges when we go to detect the edges using OpenCV. Next, we perform the edge detection also using OpenCV, and that produces this image here. And from this point on, we used OpenCV to look at the pixel data, and then we performed an algorithm on it to prepare the image data to send down to the microcontroller. So once we have the image in the edge detected format, we loop through the edge detected image and we pick out the points where there's an edge. So we'll loop through, and if we look at the pixel and we see that it's black, we reject that pixel and we don't store its location. But if we find that the pixel that we're looking at is colored or white, then we will store the position of that pixel and store that in an array. This allows us to store an array of pixel positions so that we can send those points or those positions down to the microcontroller. The next step is to take those pixels and that data from the edge detected image, and we sort that into an array where we are able to essentially make an array that will make a connect the dots or dot-to-dot image, similar to the different drawings that we did as children. And we loop through by looking at the very first pixel in the array, and then we loop through the rest of the array and find the closest pixel out of the rest of them. This allows us to connect them one by one and therefore draw the image. Before we sent the data down to the microcontroller, we were also able to do a simulation using MATLAB to take a look at what the image would look like, and that produced this image here. This allows us to take a look at it and see where there would be different connections. As you can see, because the Etch A Sketch does not release at certain points, all of the lines have to be connected from one to another, and so that's why there's the line going through different parts of the image. And that then prepares the image and the data to be sent down to the microcontroller.
Once the image has been processed, the next step is to send the data down to the microcontroller. To communicate between the microcontroller and the host PC, we make use of the microcontroller UART over the ST-Link virtual COM port. On the host side, we can automatically detect the port because it's a USB device. We can look for one with the correct characteristics to determine what COM port number the device is connected to. To actually communicate between the two, we have a simple command framework where each command consists of a name, optionally arguments, which are spaced out, and then a new line to delimit the command. We have essentially three main types of commands. One sends down a single point, which queues it on the microcontroller. The microcontroller keeps a queue of undrawn points. And then we have a command that tells the microcontroller to draw through the queue. And then we have a command that it sends back to notify when the queue is empty and it's completed the draw. So the overall process is we read in the points that have been generated from the preprocessed image. Then we send them down in chunks. And then we tell the microcontroller to draw the current chunk. We wait for it to be done, and then we repeat until we've gone through the whole image. The reason we need to send down the points in chunks is because some images may contain a large number of points, and there's limited memory resources on the microcontroller. At the moment, we're sending down chunks of 1,000 points at a time. Once the microcontroller has the points, it's responsible for drawing the path on the Etch A Sketch by controlling the motors.
On our Etch A Sketch, we have an X motor attached to the knob on the left side, which controls the horizontal direction, and a Y motor attached on the right knob, which controls the vertical direction on the Etch A Sketch. Our initial position is set to 0, 0, and then we calculate the new position relative to our last visited coordinate. This will determine how far each motor needs to move, needs to rotate, and in which direction it needs to rotate as well. We have two self-made timers in our program, and they are able to regulate the speed of both of our motors so that they stop rotating at the exact same time. For points that are really close together, this doesn't really matter, but for points that are farther apart, this will help create really straight lines between each point. Our motors move by half steps. We initially did it at 8 steps, but we were losing a lot of power to our X motor, so we had to change it to half steps, and that fixed the problem. We also noticed that on the physical Etch A Sketch, there's a little bit of lag when you're reversing directions of the knobs. And so each time we reverse directions of the motors, we have to add about 50 steps just to account for that. And that's able to make cleaner, more straight lines between each of our points. And once we finish drawing to a point, we update the current cursor value, and we repeat this process for every point that comes into our microcontroller.